So this question from differential equation, it says verify that the function, well, this is what the expression or the function given here, where C1, C2 are arbitrary constant. And what we have to prove that this being the solution of the differential equation given below. So clearly what we are going to do here is to differentiate this. Well, the number of times we'll be differentiating will be depending upon the arbitrary constant. So there are two constants, so obviously we'll be differentiating it twice. Moreover, this is a hint also that we need d square y by dx square. So let's begin with differentiating, and I'm going to apply the product rule on the highlighted portion. So let's say if I differentiate both sides with respect to x, this is going to be dy by dx c1. Our differentiation of this part is what? This is e raised to the power ax multiplied by a, and b cos x will, sorry, cos bx will be as it is. That is u dash v and plus uv dash. So u is this part, right? This is u, and v dash differentiation of this is what? Minus b sine x. So I'm going to change this sign. This is minus b sine bx, right? Now we are going to do the same thing now, this time on this one, this part. So it's going to be almost same. That is a c2 times e raised to the power ax, and we have sine bx, right? Sine bx, and then we are going to place plus sign for the differentiation of this part. So I should first write down c2 e raised to the power ax, and the differentiation of sine bx is what? This is cos bx, and we'll have a b over here. Now what you can observe, let's say if I take a common from here, is that a? Oh, no, not from this, from these two. From these two, if I take a common, this is a times y. You can pause the video and see that this is actually the one which I have colored green is actually a times y. So in the next step, I'm going to transpose this to the left hand side. This is dy by dx minus a times y. A times y is equal to, on the remaining part, I can see that we have something common. We have b common, and e raised to the power ax is common. Inside, I'll take this first, right? This is cos bx c2 times cos bx minus this, which is c1 times sine bx. Now we'll continue to apply the product rule over here. Sorry, of course, same product rule, but first I'm going to differentiate this. So differentiating this with respect to x, again, this is d square y over dx square minus the differentiation of this is what? A times dy by dx is equal to, applying the product rule here, differentiation of this is going to be what? This is a b e raised to the power ax. So this is u dash v. So I should copy the v part, u dash v. And plus uv dash. Okay, so this is b e raised to the power x. I'm copying this, b e raised to the power ax, and I'm going to get the differentiation of this. So this is what is going to be? This is cos differentiation is sine, right? So this is c2 minus sine. So minus sine. All right. We need a b as well, so I'll accommodate here. Minus b times c2 sine bx, and minus for the differentiation of this part c1 b times c1 cos bx. That's right. Now next, what you can observe, let me show you. Look into this part. Yeah. Can I say this is same as this, except for there is an extra a over here, right? You can observe over here, this is also e raised to the power ax c2b cos x minus c1 sine bx. So I can replace this with what? A times of this. This is what I'm going to do in the next step. So look into this. This is d square y over dx square minus a times dy over dx. And as I said, this is what a multiplied by this. So if I write it, say on the right hand side only, this is multiplying a over here, right? So a times dy by dx minus a square y. So let's understand this again. What I'm going to do is to replace this thing with a times of this. So that's why I wrote this. And from here I can see b is common. In fact, minus b is common, right? So I'll take minus b common. So there is a b already outside. So it's going to be minus b square e raised to the power ax. And the remaining, I'm going to copy this. I'll be writing this first. That is c1 cos bx and plus, right? Since I've taken minus common. So try adjusting it over here. This is c2 sine bx. Okay, now check here. What you can see here, this is y, right? Can I say this is minus b square y? Check here. They are same. If you are going to take e raised to the power x common from here, this is nothing but b. You may pause the video to see this. Let's do the simplification part now. This is d square y over dx square. And if I bring this to the left hand side, it will be same term. So I can write this is minus 2a times y twice because the same term being added. And this on the left hand side will give you a square y. This, as I said, this part is b. Oh, sorry, y. This is y, right? So I can say that this is minus b square y. So if I write on the left hand side, it's going to be minus b square. Right hand side is minus, so left hand side positive b square y. There's nothing on the right hand side. So now I think we got it. This is d square y over dx square minus, that's 2a dy by dx. Now the only change we need to do is to take y common from here. So a square plus b square times y is equal to 0, right? So if I see what we had to prove, let me see if I there, yeah, it's there. Okay. Right. This is what we needed to prove, right? I think it's better if I see. Yeah. This is what we needed to prove, d square y over dx square minus 2 times dy by dx. And this is positive. Yeah, that's positive only. Minus 2 times a. So we proved it.